Good evening, everyone, and welcome to the New Hampshire Archaeological Society 2021 Archaeology Month presentations. My name is Dick Bovair, Secretary of the New Hampshire Archaeological Society and your host for this evening. Today, we're excited to welcome Dr. Nathaniel Kitchel, who will speak on new data he has generated from the remains of a mammoth recovered in Vermont in the 19th century. Nathaniel is from Danville, Vermont, and has been a volunteer in the New Hampshire State Conservation and Rescue Archaeology Program since 2006. He obtained his MA from Northern Arizona University and PhD from the University of Wyoming, and is currently a postdoctoral fellow at Dartmouth College. Welcome, Nathaniel.
Really happy to be here to talk about some of the recent research I've undertaken, or some colleagues and I have undertaken into the Mount Holly mammoth in Mount Holly, Vermont. And tonight, what I'm going to try to do is place these recent findings that I'll discuss later in sort of a historical context of the archaeological research and their implications for sort of continental scale understandings of human megafaunal interactions, which I'm sure will become apparent can sometimes be pretty fraught. Some of these discussions can be get a little heated at times in terms of archaeological research. Before I get into the mammoth itself, I want to start kind of at the beginning, at least in terms of the quaternary paleontology of New England, right? And how New England is indeed very much how New England was indeed very much a different world during the late Pleistocene, more than 12,000 years ago. So as many of you know, I'm sure, the landscapes of New England are shaped by ice. Right, shaped by multiple glaciations, the most recent of which peaked maybe 28,000 years ago, and then ice started to recede sometime after that. Now, this had the effect of shaping the lands that we see today, grinding down mountains, carving valleys, and also removing any relatively recent paleontology that would have been present in that region. It sort of got ground to powder and pushed out into the ocean. It also had the interesting effect of pushing the land down in many places, again, creating very much a different world. So after the ice retreated, as in this graphic, right, very much a different world. New England would have been something like a maritime peninsula, because although it opened up the well-known Champlain Sea, although ice would have still been, let me see, get a pointer, would have been here over the Canadian Shield, right? The St. Lawrence Seaway and Lake Champlain would have been ocean. We know this because there is a beluga whale also found in Vermont. However, the weight of the ice also pushed down some areas of the coastal shelf, not necessarily at the same time, but in parts of northern Maine, you actually have glacial-marine deposits, undersea deposits that stretch up to within about 50 miles of Mount Katahdin. Again, a completely different world than what we would recognize today. Now, and inhabiting that world were a whole menagerie of sort of fantastic beasts, at least in other areas of North America, from mammoths, mastodons, gomphotheres, giant sloths, camels, armadillos the size of Volkswagens, a whole host of fearsome predators, the American lion, dire wolves, short-faced bears, a bear that could that allegedly hunted in packs and could have run perhaps 45 miles an hour, right? All during a period that would come to be known as the Pleistocene. And as a matter of fact, these animals, these now extinct animals of the Ice Age, right, are in fact index fossils of that Pleistocene epoch, right? These now extinct megamammals or fossils thereof are indicative of that different world of the Ice Age, the Pleistocene. And as it so happens, the Mount Holly mammoth, found in 1848, played a role, an important role, in scientists beginning to recognize what this epoch was like, and begin to recognize that the Ice Age was in fact a thing that happened. Now, some of the documentation from the time is a bit more fanciful, suggesting that the finds of mammoths or the finds of elephants in more northerly regions indicated that the Earth was once closer to the sun and therefore much warmer. However, these ideas didn't persist, and it soon became clear that rather than being warmer, this is actually a time period that was colder. and that these elephants, mammoths, mastodons, gomphotheres, collectively proboscideans, inhabited this colder world. So in 1848, the Mount Holly mammoth was among the first well-documented finds of mammoths or mastodons in North America. However, at that point, we would have to wait over a century to find out just how long ago the Ice Age or Pleistocene epoch was. Now, importantly, as markers of the Pleistocene, of the Ice Age, these now extinct animals were key to understanding a contentious and ongoing debate in early American archaeology. And that was, in particular, when did the first humans arrive in the Western Hemisphere, in what would become to be known as the Americas, right? So, although the antiquity of the human occupation of the Americas wasn't originally contentious through various policies, often many of them rooted in racism, it became sort of de rigueur for archaeologists to argue that the human occupation of the Americas was relatively recent, perhaps as little as 5,000 years ago, right? In that, and therefore, humans did not overlap with these now extinct animals, right? Now, this debate finally reached a conclusive end in the 1920s at the Folsom site in Folsom, New Mexico, where this fluted spear point was found between the ribs of a now extinct species of bison, a bison antiquus. Now, at this point, scientists and archaeologists didn't actually know how old those remains were in calendar years, or in years ago, but only that this was an unequivocal human-made artifact directly associated with a now extinct animal that was itself a marker of the Pleistocene, of the Ice Age. Right? Only a few years later, another style of distinctive projectile points or bifacial knives was found associated with a mammoth at Blackwater Draw, thereby conclusively demonstrating that humans had in fact overlapped with megafauna and with elephants at least in the western part of what's now the United States. Here you can see some distinctive Clovis points. These are actually from the Drake Cache. These are not the Blackwater Draw points. These are Drake Cache Clovis points from Colorado. Now, as many of you know, here in the Northeast, fluted points also manifest. And I will thank Dick Bovair for this figure. And I have purposefully cut off a Clovis point, which actually sits here, because many archaeologists working in the region argue that Clovis points, sensu stricto, right, in the strictest sense, do not appear in New England. But we do have unequivocally fluted points in the region of various styles: Bullbrook, Michaud-Neponset, Vale de Bert, and Kings Road Whipple. Bullbrook, Vale de Bert, and Kings Road Whipple accepted to be some of the older points and predating the Michaud-Neponset points. Now, when the first fluted points were found, archaeologists still did not know precisely how old these points were in calendar years. They were found before the development of radiocarbon dating. And though it seems sort of old hat at this point, sort of routine in archaeology these days, I think it's worth revisiting just how transformative this was for not just archaeology, but the earth sciences in general. So radiocarbon dating, invented by Willard Libby in 1949, so really relatively recently, in terms of the centuries-long discussions about antiquity of animals, the Ice Age, and humans in around the world. So at the University of Chicago, blooming out of the Manhattan Project, right, studying of radioactivity, and ultimately Libby was awarded the Nobel Prize in chemistry for his findings. And primarily what he found was that a radioisotope, a radioactive form of carbon, decayed at a knowable rate. So Willard Libby calculated this half-life, or the time it takes half of that carbon to decay, at 5,500 years. It's now been recalculated at a little over 5,700, right? And Libby calibrated these ages based on things of known age, whereas, so for example, tree ring dates where you could count backwards in time, as well as things that actually had dates written on them, like Egyptian sarcophagi. Now, the really important aspect of this is that the advent of radiocarbon dating and other radiometric techniques really opened the door to deep time, right? So we could now know that the Folsom site was about 12,700 years ago on a calendar, right? And we could date those bones, not the point itself, but just the bones. And with the development of this technique, this is exactly what many archaeologists and earth scientists and paleontologists set out to do. And date away they did. And an interesting pattern began to emerge when you started dating the earliest archaeological sites throughout the continent, all associated at that point with these fluted points for the most part, and then started dating the last of the Ice Age megafauna. They found, archaeologists found that the very last of the megafauna seemed to overlap or be associated with the very first people. Right? And a paleontologist at the University of Arizona named Paul Martin formulated this idea that these were related. Now, Martin called this, somewhat unfortunately, perhaps very unfortunately these days, the Blitzkrieg hypothesis. The idea that the first humans entered into what's now North America, found a whole menagerie of naive prey, that is animals that had no idea that humans were some of the most dangerous creatures they could possibly encounter on the landscape, right? And since they had no fear of humans, they were very, very easy prey. Now, later on, Robert Kelly and Larry Todd hypothesized that this was what allowed fluted point technology to spread so widely across the continents apparently so quickly, right? That these naive prey would be quickly hunted, out in a given area, and people would simply move on, leapfrogging very quickly from naive prey population to naive prey population, ultimately causing the extinction of these animals throughout the continent. This has now been rebranded as the Overkill Hypothesis and has become something of a spirited debate in American archaeology. Now, this debate centers around whether humans could reasonably be responsible for the extirpation and ultimate extinction of many of these now extinct animal species of mega animals, or if alternatively, climate change that was taking place at the same time is perhaps a more reasonable culprit. Now, Don Grayson and David Meltzer have argued that Paul Martin's overkill hypothesis is not valid, primarily arguing that there are many other species that were not hunted, including some species of very small mammals, including a mouse, and in one instance, even a spruce tree went extinct at the end of the last ice age. Right? So saying not only are human artifacts rarely associated with these megafaunal species and almost exclusively with proboscideans rather than giant ground sloths or short-faced bears or camels or horses or anything of that nature. Really, there just isn't good evidence for human overhunting of these animals. Now, counter to that, Todd Serval and Nicole Wagaspak have argued that, in fact, if you look at the time frames over which these hunts may have been taking place, there are actually a lot of elephant kills. Meltzer and Grayson, at the time that this paper was written here, had accepted by some very strict criteria that they came up with, or modified from previous scholars, that there were 14 really good Clovis human mammoth mastodon associations, right? And Serval and Wagaspak argued that, in fact, well, 14 might not sound like that many, but in fact, that's quite a few. Now, going by these criteria and updating them with a few modern sites, this is the map you get. These human mammoth associations can absolutely be quibbled over. I'm not trying to make a particular value judgment about which ones should and should not be accepted. I know that there are probably some sites on here that some folks might feel have been unfairly left out. I would ask that you not take that up with me, but rather with Dave Meltzer and Don Grayson. I'm merely going from their data. So of the 14, I've now added another 2, One is here in Mexico. That's the Fin del Mundo site, which is an interesting one because it's quite old, a little older than a lot of Clovis sites, which tend to be around 13,000 years old. Fin del Mundo is like 13.4 to 13.5. And then the Leprel mammoth, another mammoth kill, unequivocal mammoth kill, or human mammoth association in Wyoming, which has recently been excavated by none other than Todd Suravel, and ongoing work there. Now, this debate extends to the Northeast with this paper by Matt Boulanger and Lee Lyman, who pointed out that not only are there no really strong candidates for human mammoth associations in the region, but that humans and mammoths don't even really seem to overlap in time. So if humans and mammoths don't really overlap, or humans and megafauna don't really overlap in time, humans can't really be implicated in the demise of these creatures, right? And these are some of the figures from the Boulanger and Lyman article, right? Showing here's radiocarbon dates from megafauna, here's radiocarbon dates from humans, and really the peak for megafauna doesn't even begin to overlap with the peak for humans. Same thing showed here in the bottom. It's a different way of modeling those dates. Now, returning to the gelatinous muck of Mount Holly, as it was described by one author reporting on the finds, right? Beyond the tusk that was pictured here, in 1848, another more degraded tusk was found, as well as a molar and an unspecified number of bones, right? Now, although the remains were originally supposed to be donated to the Geology Museum at the University of Vermont, which is now the Perkins Museum, the remains were ultimately transported to what was then Harvard College, now university, for further study by John C. Warren, who was then writing a book on elephants in North America, Elephas primigenius, which would later become Mammothus. And also Louis Agassiz, another preeminent geologist of the era, who has now been implicated in some pretty terrible race science, but nonetheless, he was an eminent geologist of the time. Though sometime prior to 1865, Agassiz returned the tusk, the best preserved tusk, to Vermont, as well as a cast of the molar and a few other bones to Vermont, to the University of Vermont. That's the tusk pictured here, while Warren retained the other portion of the remains at Harvard, ultimately incorporated into his private collection, which were purchased by J.P. Morgan and donated to the American Museum of Natural History in New York, where they remained until 1920, when they returned to Harvard. The materials returned included a molar, and as well as unspecified skeletal elements. And a recent inspection of these materials seems to indicate that there are multiple mammoth individuals represented there, as well as mastodons, and there is no record of any mastodon, let alone another mammoth, from the original documentation of the Mount Holly find in 1848, indicating that these materials have probably become commingled with other proboscidean remains from elsewhere, right? Except for the molar. The molar is pretty well documented. Now, the story of these remains made it pretty unexpected when, as I was invited out to the offsite storage facility at the Hood Museum of Art at Dartmouth College, when I stumbled across this in the New England section of their storage facility. And this is a rib that had previously been found in 1848. And as you can see, maybe see here on this sticker, this says rib of fossil elephant, Elephas primigenius here in black, Mount Holly railroad cut, presented to the museum by a W.A. Bacon Esquire. I will point out, I had previously found record of a William A. Bacon in Ludlow, Vermont, just down the road from Mount Holly in 1852, where he was publishing a weekly paper called The Blotter. However, recent research and investigation by an interested member of the public has now found that not only was Bacon living in Ludlow in 1848, but that he was actually working as a surveyor for the railroad, now providing a direct link between Bacon, the railroad, and how he may have come across this rib. But this discovery was unexpected because none of the primary documentation indicated that another rib had been found and taken by Bacon and then subsequently donated to Dartmouth. And the museum also had no record of this particular item in their catalog. Now, this is pretty exciting because I'd recently gone up to Mount Holly to give a talk about my primary research, which is the human occupations of Pleistocene, the Pleistocene Northeast. So I'd spent a little time learning about the Mount Holly mammoth, and I knew that it actually had not been radiocarbon dated. Though we know obviously that it dates to the Pleistocene, didn't know how old it might be in calendar years before present. So my colleague, Jeremy De Silva, and I submitted a sample of this rib to the Center for Applied Isotope Studies at the University of Georgia for an accelerator mass spectrometry date, a fancy radiocarbon date. Now, this produced an unexpected result, which was that the rib dated to 10,860 radiocarbon years before present, or calendar years 12,790 to 12,690 calendar years before present. Now it's unexpected, not because we didn't think that mammoths survived that long. There are plenty of radiocarbon dates from the Western United States with mammoths into the Younger Dryas. And not that we didn't expect this to potentially overlap with people at some point in other parts of the continent. But in New England, this is actually pretty rare. There aren't that many well-dated proboscideans, mammoths and mastodons from the region, and very few with a date that's even remotely this recent. So I say this is unexpected because we actually had a bit of a pool, those of us that are in the archaeological community interested in mammoths, as to what this was what the radiocarbon date would come back to. And I guessed around 14,000 years before present, because that's been a pretty strong pattern and you don't want to jinx yourself when you're doing these sorts of things. So in Vermont, or in New England, in the New England states, right, there's only a handful of well-dated proboscideans. And of those, the Mount Holly mammoth here is by far, is the most recent, with a relatively well-constrained date. As you can see, the Berry mastodon from the Atlantic Ocean, right, also is a relatively recent date, but it's got a much larger standard deviation, so we're much less certain about when that happened. So this makes Mount Holly one of 9 other proboscidean finds that have been dated in New England, and the youngest yet dated, with the most secure date. Although it does, again, substantially overlap with the date from the Berry mammoth, but that's largely because of a really large standard deviation. Now, it's also unexpected because many of the other proboscidean finds from New England are either associated with the ocean. Here, a number of finds from the Paleo-Merrimack River Delta off the coast, generally teeth dredged up during fishing. The Scarborough mammoth, which is now on land, but was actually deposited in the ocean in those marine sediments that I talked about earlier, and several lower elevation finds in Connecticut and Massachusetts. And Mount Holly sits up here at the top of the spine of the Green Mountains, so not only is it remarkably young, it's also in a relatively weird location for these other animals. And it's the only specimen from Vermont. And I'm sorry to be talking to the New Hampshire Archaeological Society, because to my knowledge, other than the ones that have been found at the Paleo-Merrimack River Delta, there aren't any dated proboscidean finds from the state of New Hampshire. Also, this relatively recent date brings the interval of humans and proboscideans, humans and megafauna, closer together here in New England, right? It shouldn't be surprising that this is possible, because of course we know that humans interacted with megafauna in the Western United States, and indigenous oral traditions amongst many groups in the region also speak of elephant-like creatures. So this should be viewed as a distinct possibility, but no material evidence had yet been found that this was happening, right? That the proboscideans tended to be much older than the first arrival of humans in the region. And the Mount Holly mammoth date now has moved this slightly closer together. So I think that that's really, really cool. Now, it doesn't provide any material evidence that humans had anything to do with the demise of this creature. However, it does raise a possibility that the first humans in the region did in fact share the landscape with and perhaps interact with some of the last megafauna in the region as well. But there's more. And for those of you that are like me, that are interested in in how animals respond to climate change and what that can tell us about the past environments. Part of this radiocarbon analysis also included an analysis of stable isotopes, which give you a bit of a window into what animals were eating. Now, without going into too much detail, mammoths tend to be really enriched in nitrogen, which actually is unusual because usually that happens with carnivores, right? So carnivores usually have really high nitrogen, stable nitrogen values. Mount Holly mammoth is actually quite low. And what we're looking at here is mammoths at the top and mastodons at the bottom. Now, why this may be precisely, now what it is that mammoths are doing to get these really high nitrogen values is not necessarily known, but it's thought to be behavioral, that they are either really picky eaters, or maybe they're eating earth, or perhaps even eating their own dung, or eating really specific plants that are enriched in nitrogen. But the Mount Holly mammoth sits down here with mastodons. And this is pretty unusual for mammoths, but not entirely unknown, as it looks like some of the latest mammoths that we have evidence for, stable isotope evidence for here in North America, actually show this trend of reduced nitrogen. And what has been hypothesized is happening is that these animals are actually changing their diets in response to changing environments, right? So it looks like the Mount Holly mammoth may very well have been inhabiting a Vermont that was really changing from what it was like in the Ice Age to become more of what it's like now, just before these animals went extinct in the region. So while preliminary, the results from this first radiocarbon date of the Mount Holly mammoth, I think, are actually really super cool, providing some clues, some indication that that mammoths survived here long enough, or proboscideans survived in the Northeast longer than originally, or longer than had been expected previously, based on previous evidence, and maybe, just maybe, shared the landscape with some of those first humans, as well as inhabiting a changing environment in the state. Now, there's a lot more work to do here, right? This is only one radiocarbon date in stable isotope analysis. And one of the things we really need to do is confirm the taxonomic identity of the rib, right? The only, and what that means is, like, confirm that it's in fact a mammoth, right? We have this weird stable isotope value. The remains that have been documented at Harvard seem to have become commingled, but the taxonomic identification of this rib as a mammoth is based only on its association with the bog, and it was actually found scattered across the bottom of the bog. It wasn't a neat, tidy skeleton. So is it possible that another individual, perhaps a mastodon, was present in that pond? Yes. Do I view that as unlikely? Also yes, but it's worth checking, right? Same goes for the radiocarbon date, right? Materials can become contaminated with newer carbon. You can imagine how much carbon could be running around in the bottom of a bog for 12,000 years. So without very careful pre-treatment and cleaning procedures, right, this it might be that this date is just a little bit too young. So we need to check our work, so to speak. I'm also interested in obtaining additional radiocarbon dates for other megafauna in New England. Not necessarily just mammoths and mastodons, although that would be cool too. So if anybody knows about any, I'd love to hear it. And then also test the Mount Holly site for the presence of intact deposits capable of preserving additional mammoth remains. Remember, this was only a railroad cut excavated through this bog, so it's entirely possible that more of the skeleton is present. And then, as sort of a Hail Mary approach, perhaps go up to that bog and also do some archaeological survey to see if there's any indication of a human habitation in the area, which I view as a relatively remote possibility, but it's not that hard to check. With that concludes my talk. I'm happy to take any questions that you might have, and thank you so very much for being here.
Okay, so we have the opportunity to take questions from the audience. I'd just like to start off with two things. What does the bog area in Mount Holly look like? Just give us a sort of a environmental description of it. And are there any Paleo-Indian sites, in the vicinity?
So the Mount Holly Bog itself is a relatively nondescript wetland area in in the broader Northeast. I think other than the Mammoth, it's quite interesting because it is in fact a hilltop bog. It sits right at the spine of the Green Mountains, almost exactly on the drainage divide of the southern Green Mountains, where water on one side of it goes to the Connecticut River Valley and the water on the other side goes to Lake Champlain. So again, sitting right there at the top of the Green Mountains. But if you just walked by it, you probably wouldn't notice much about it. Alder and willow thickets around the outside. There's some open water, which might be a product of dredging by the railroad towards the middle of the pond. It's a number of acres. I don't know how many, and it has a weird siding out into it that was also constructed by the railroad, perhaps at a later date, but itself relatively nondescript. The nearest Paleo-Indian site, the nearest Fluted Point site is the Jackson Gore site in Ludlow, just a couple miles down the road on the eastern side of the Green Mountains, near the base of the Akimo ski area. Now, it's absolutely fascinating to see that site so close to the find spot of the Mount Holly Mammoth. But I do want to emphasize that the Jackson Gore site almost certainly post-dates the demise of the Mount Holly Mammoth by at least 500 years. The Jackson Gore site is a Michaud-Neponset phase Fluted Point period site, so it's somewhat younger than the oldest Fluted Point sites in the region.
Okay, so realizing that we're stepping into some minefields with a pogo stick, where would be the closest association of mammoths or mastodons and people? I mean, the map looked like you have a pretty long walk to get there. Is that really the case?
That is going to depend upon who you ask. As I was at pains to emphasize, that map is based on the criteria set out by Don Grayson and David Meltzer, which are considered by a lot of researchers to be perhaps too strict. There are a number of human mammoth finds or proboscidean finds in the east that seem to have perhaps reasonable probability for human mammoth associations. Folks might be familiar with the really early Page Ladson site, a submerged site in the Osceola River of Florida. Dick, I know you've talked to many of us scrappers about the site you worked on in Kentucky with the stepping stones placed around the mammoth, also in a bog, or mastodon, excuse me, I'm sorry. There's also a couple of sites, at least one site in New York, the Hiscock site, which has been argued to be a human mammoth association. Mammoth, mastodon, a human proboscidean association. However, that site has been evaluated by Grayson and Meltzer, and they felt that it didn't meet their strict criteria. So there are contenders out there, and I don't want to be the one to arbitrate those. It's not really what I do. But for the purposes of this study, I go by what has been presented previously in the literature.
Okay. We have a question here from Mark. I suspect it's Mark Toporowski, but if it's another Mark, please announce yourself. It says, Dan Fisher from the University of Michigan has recently presented information about a mammoth find in Michigan, perhaps the bristle mammoth. This site had boulders holding down a large chunk of mammoth underwater for later use. Do you have any thoughts about this particular site? Are you familiar with it?
I am vaguely familiar with that specific site, but far more familiar with Dan Fisher's larger body of work. Fisher has argued for years and years, since the 80s, that a very, very large number of proboscideans found in bogs and wetlands and other environments like that in the mid-continent, particularly in Michigan, are, for various reasons, were placed there by people. And he has developed his own specific, sophisticated set of criteria to evaluate that, claiming that these animals were placed there for the purposes of meat preservation. In spite of all that, his ideas have not gained a lot of traction in the wider archaeological community. And generally speaking, though the folks that study this don't usually accept Fisher's mammoth finds as unequivocal human mammoths association or human proboscidean associations. It's kind of, they all have a bit of an asterisk by them.
Okay, another question from Charles Finney out of Knoxville, Tennessee. We're getting a nice audience here. So if mammoths and mastodons were changing their diet in response to climate changes, have any changes in skeletal structure, which is to say size, bone density, etc., been observed, or is the sample size too small? In other words, do we see changes in the latest Pleistocene proboscideans from the earlier ones in terms of their actual physiology?
As far as I know, no. At least not in the not in the areas in the continental part of the continental parts of North America. Now, there are a couple of examples where mammoths were isolated on islands. A famous example being Wrangel Island, where they actually became subject to island dwarfism, so they shrank. I haven't read anything in my research for this that indicated that happened in areas that weren't on islands. And it doesn't necessarily appear that these most recent mammoths that have been found in the paleontological record, or mammoths and mastodons that have been found in the paleontological record, are really suffering any sort of nutritional stress, but only that they are changing their diets than what had been previously observed in other older specimens. What that may mean, I think, is open for interpretation. So I wouldn't want to speculate upon it.
And do you have any thoughts on the mammoth and mastodon remains that have been found off our New England coast? We've had a couple pop up in the last 10, 15 years off the shore of New Hampshire and northern Massachusetts. And separate from that, what do you think of the engraved mammoth sketch from Vero Beach?
It's really, really hard to evaluate what's being dredged up off the bottom of the ocean, right? Because those of us that do archaeology know that context is key. And when something has been dredged up off the bottom of the ocean, most of that context has been lost. So even if you're getting artifacts coming up in the same scallop dredge as mammoth remains, it's really difficult to know just how they may have been related to each other in terms of stratigraphy and even space. I don't really, I guess I don't really know enough about the engraving at the old Vero Beach site to make an informed, take an informed position on that one way or another. But in most instances where there have been representative drawings of proboscideans in North America, they've been accepted by some and not by others, as is the nature for a lot of these finds.
Okay. When and if you go back to Mount Holly, in an ideal world, just what would you do there in terms, I'm thinking sort of broad theoretical question right down to your recovery methodology to answer those questions. In an ideal world, what would you do at Mount Holly?
In my mind, it would be very much a stepwise process. First things first, I'd do a lot more remote sensing. So colleagues of mine from Dartmouth, went up there this winter over the ice and ran ground penetrating radar over the ice of the bog, right? When it's easiest to access a bog because they're terrible places to walk in the summer, but tolerable in the winter. And you can move more freely around those areas. And simply to evaluate the GPR as a technique in that particular bog and just see what we see if we get any meaningful results. And we're still working on processing those data. It looks like something might be coming out, but we need to do more work. And ideally we'd go back to try to identify any anomalies that might be present towards the bottom of the bog. Now, as it stands, GPR is not really great. It's quote unquote seeing bone. But you maybe just maybe, if it was big enough, dense enough, and it stood out enough against the icky muck of the bottom of that pond. I think then moving forward, the simplest way to do anything is just to put a core down into those deposits and see what's there. Take a date from the bottom and just see what you're looking at. It's particularly unlikely that you'd bring up any pieces of bone, but you want to start there and just see what happens. I don't know about the, I'm not convinced about the need to go mucking around 12 feet down in a saturated environment, not knowing whether proboscidean remains may be down there or not. That's a difficult proposition. Some people are perhaps more interested in doing that than I am, but it conceivably is possible if there would seem to be something really, really interesting there. And then, like I said, I think I view it as an unlikely possibility, but not unreasonable to go and see if there is some, Paleo-Indian age campsite associated with that bog. If you happen to find some fluted points right next to the edge of that pond, it would be pretty unlikely that they were there by happenstance, given the scarcity of fluted point sites, not just in New England, but everywhere else in North America. So these are all ways forward. But obviously the easiest thing to do is simply go to the remains that you have that have already been excavated by virtue of railroad construction and do the best that you can with what you have there. So there's going to be some of that as well, I hope, in the future.
Okay, and this seems like you're being tested on every known dead elephant in North America. Also, any thoughts on the not so big mammoths at Santa Cruz Island in California? Does that fall into that island dwarfism business?
Yeah, I believe that they do, and I don't know of any accepted human mammoth associations on the Channel Islands. But yeah, it's a pretty common phenomenon when islands do weird things to animals. Big animals get small and small animals get big. And the same thing has been shown to happen to elephants on more than one occasion, not just here in what's now North America or the Americas, but around the world. In fact, the island of Flores with the well-known Homo floresiensis spine, there are also miniature elephants there as well. So it's a fairly common phenomenon.
Okay. Coming back to New England, what do we have in the way of any sort of sites in bog circumstances? We certainly have some bogs in New England. Are you familiar with any bog-related research? Maine, New Hampshire, Vermont, even Massachusetts.
Specifically focused on archaeology?
Yeah.
To my knowledge, no, but I will also say that I haven't honestly been looking that hard. I haven't been sort of jumping to get myself into a bog, but certainly if it came to that, I would look into that more deeply. I'm more familiar with this, some of the work on saturated sites in Europe, but to my knowledge, I don't. And other people are probably better equipped to answer that question than I am, honestly.
Just a question from me at Mount Holly. Do we know enough about the bog that we could consider just sending down a core and carbon dating down the core itself to see how the dates shake out and when it began, when certain things happened? Presumably you can get some identifiable flora in
yes.
the bog. Do you think there's any value to that kind of study of the bog itself?
I absolutely do. It's certainly something that I would hope to do in the future. I've talked to some folks about it, and maybe when things freeze up again in the winter, we'll have that opportunity. It's just a matter of getting people with very, very busy schedules all together to accomplish anything, and that can be quite a challenge. But yeah, I absolutely do, because while there's the indication that the mammoth was changing its diet, we really don't know what the paleo environment of the summit of the Green Mountains 12,800 years ago actually looked like. Was it an open environment? Had trees started to colonize the region after the retreat of ice? Both are possible, I think. And there's some evidence that, actually pretty good evidence that these mega herbivores are really powerful ecosystem engineers, right? African elephants actually stop forests from growing and maintain savanna by knocking down trees, consuming them and eating them. Oh yeah, absolutely. And the same processes may have been happening with mammoths and mastodons in, well, actually all over the world where they were found. They may have been in part responsible for maintaining the somewhat unusual Pleistocene environments that are found many places at the end of the Ice Age. Yeah, really powerful engineers of their own environments. Yeah.
Okay. Well, is there anything else that you'd like to tell us about this site or your thoughts on further research? We've pretty well exhausted our barrage of comments of elephants for 1,000 here in North America. So if you could just kind of wrap it up for us, I'd appreciate it.
Yeah, I think if I've taken anything away from this research is that you kind of have to be prepared for the unexpected, but also be willing to look for what might be out there. And what I'm really interested in is establishing now broader patterns. We have one data point. We have the one radiocarbon date from the Mount Holly mammoth, and only a handful of others from New England. And the folks that are going to find those remains elsewhere that may still be out there are going to be people that are in the audience, or people who are in the audience might know that, maybe their grandfather collected a mammoth or mastodon tooth from a riverbank 100 years ago. Those objects actually have great research value. You can learn a lot from them. So I would really just emphasize to people that if they know something, that if they know of any of these remains, be it mammoths, mastodon, anything else, right? There's real value in actually taking a deeper look at them. And I would be really interested to learn more about what folks in the community might know, right? Like that's been the really cool part is, the folks at Mount Holly are super interested in the mammoth and all things to do with the mammoth. And it's been great working with them to learn more. And it's actually because of them and inviting me up to speak at their Mount Holly Community Museum that I actually knew what I was looking at when I walked into the Hood Museum of Art. So you never know what might come or what you might have in that old shoebox in the closet.
Okay, great. Thank you. Well, thanks, Nathaniel. We really do appreciate talking with you this evening.